support system for planning and design using GIS, VR, and information communication technology. He also editor-in-chief of the IRSCPD International Indexes Corpus and XE, and also some of the another reputable journal. So good morning, Professor Shen. So please, Prof, platform is yours. Would you please to unmute yourself, because apparently we cannot hear it.
I'm sorry, I muted my speakers.
It's okay,
thank
Prof.
Thank you very much for inviting me to give this talk and have this chance for communication with you. I think I have the total here 20 or 25 minutes for this talk. And firstly, I'd like to thank Dr. Iriwan to invite me to join this great event. And also thank for the members from the UNS and other keynote speakers. And thank you for the moderator, Ms. Dewanti, for moderating these sections. My topic is simulation for urban planning and design. And today, recently, I have a chance to summarize all my research work in Japan. So also probably this topic also relate to the topic of the conference, the environmental and the sustainability conference. And this introduce myself. I think the Ms. Dewanti already introduced. So I originally from China, and now I'm working in Kazan University. And my research is in the field of urban. And so my topic today can be divided to the three parts. And I'm doing research work in the field of urban simulation and virtual reality for support urban design. And all my research starting probably can images about the start from the human behavior and to the urban planning design and to the construction. So I will introduce my first part is agent-based model and simulations. And all this work is supported by the Japanese governments like the JSPS project. And my thinking for the urban simulation is like in Japan, we call the planning process as the planning framework. We start from the economic demand allocation, and then turn to the land development, including housing and public facilities. And then the people will occupy the land parcel, and then they will have the transportation in the urban areas, and they will cause some environment issues. In local city in Japan, like Kanagawa city, they start from the urban development, so we call it urban sprawl, and develop their business areas outside in the suburban areas. And then in the downtown, they will cause the urban decline issues. And then most population living in the downtown areas. And so there's a process like here, I show here is like start from urban sprawl and urban decline. And also downtown revitalization, this is quite important topic. And I will introduce some urban planning and simulation work today. And the first is a downtown regeneration policy. As you understood, I already introduced the development to develop the residence use in suburban areas. And so the downtown tend to decline. And this is the urban planning area of Kanagawa cities. And in the left side, you can see there's the density of population. And in the right side, in the red part, is the downtown areas, and the blue part is the suburban areas. So there's a lot of residential development projects in that areas, and the government like to ask people to move from the blue part to the red part. So that's the urban residence promotion policies. They have some subsidy program for the people who like to move from the suburban area to the downtown. The government pays some, they will pay some subsidies for the people who move. And for this, as I introduced first, consider our simulation from the period. So firstly, we consider the household occupation. So we consider the life cycle stages for each household who living in the downtown areas to simulate when he will, in what kind of condition he will move to the suburban to the downtown areas. So firstly, we define the where's the stage of the people who will consider the relocation. We in Japan, we find that the three household ages they will be possible to consider relocation. And first is the 20 years, and then get married in the 30 ages, and probably they have the children, a big family, they will move to a big house, and after the children became independent and he became the aged person, probably have another chance to consider relocation. So in the fourth stage, it's possible for the household to use the urban residential promotion policy to move to suburban areas to downtown areas. So this is some kind of simulation. We use the virtual city of Kanazawa and simulate the urban policy and the urban condition of the urban policy inside the simulation system, and simulate the people, how the people move from downtown to move from the suburban areas to downtown. And for the people who will choose the downtown as their relocation areas, we make more than 10 years investigation for checking where's the impact factors for the relocation behaviors. So in the background of this slide, you can see there's a lot of factors that is we collect from the questionnaire in Kanazawa cities. And this is just an example of our simulation work. And totally we will, how to say, we develop such kind of system. In the right side is the decision making, is for the decision making meetings. And in the right side, you can see there's a server side. Server side, you can imagine that the mayor will use the server side, and different department of the government will use the client side. This means the residential bureau or the transportation department or other organization in the cities. And the client can choose their own policies, and the mayor can check the comprehensive simulated result of all the supposed proposed policies by each department. And then mayor can make the final decision of the local city's policies. And we have done a lot of such kind of simulation works. Some work is published as in a journal. We have that here. We show two related journal. If you are interested, you can find this journal to read and ask more detail. So another one is about the disaster prevention and accommodation shelters. In Japan, there's a lot of that of disasters, including the earthquake. And as you can see here, is the cover of cities, which this map show the degrees of the earthquakes. And then we simulate which building will damages and which road will be blockaded in the when earthquake taking place. And we simulated the evacuation behavior and find the people who evacuees for how they will find the accommodation shelters in Canada cities. So this is the GIS data we use for the simulations. There you have the building data and all the road network data. And then we can simulate which building will be damaged during the earthquake and calculate, and then we can figure out how many people will leave the damaged house to the accommodation shelters. And when the people find the evacuation route, actually they cannot use the road blockaded by the earthquake and by the debris of the buildings. So this that is methodology, we simulated the how the road will be located during the earthquake. And then finally, we'll get to such kind of results. You can see the start mark in yellow card is accommodation shelters. And the green, the point is mean the damaged buildings. And the people, I mean the evacuee will escape from the buildings. And they choose the red road network as evacuation road to the start mark, mean accommodation shelters. And then we can summarize how many people will use the accommodation shelters. And because we have the data, the capacity of each accommodations, and then we can figure out which accommodation shelters is in the dangerous status. And the buildings is mean they will cause the road blockaded in this map. And finally, we will understand which accommodation shelter is in the risk and which is safe. That is mean the number of evacuations will over the capacity of the accommodation shelters. So that's the result of the simulation. So there's also have two papers that published in the Nature Hazard Review and Disaster Situations. So if you are interested, you can find the two channels for more interesting, more information. And so this is the urban simulation work. Actually, we start from the consider the economy of demand allocations, and then we consider where to develop the housing and commercial and public facilities. And then we can simulate the interaction between the land use and transportation. And then we consider the environmental impact in the urbanization process. So that's the old consideration we are doing in the field of simulation work. And now let's start to the second part. The second part is about urban design. They also support many by Japanese governments and local cities governments. We are interested to simulate the urban planning regulation. We have developed a tool you can see here. This is a building, the possible the stories, and then we put all the parameters of road regulation and the planning regulation in law, and we simulated how regulation will look like, and also we can put in the how the planning regulation will impact the building strength. And this is very useful for public transportation. And also, we have such kind of tool or invite the people to design the public park in their communities. For this kind of work, we use the virtual reality to support the planning, urban design. They also have some urban design work to simulate the house. In this case, is the government like to build a pedestrian bridge, and we find a solution for the transportation traffic jam. Divide the people and the car in the different level. So this and we simulate the effect of the design of the pedestrian bridge to find it's the problem traffic jam can be solved by this kind of design. So we simulated the amount of car, and also we simulated the number of the people in the crossroad based on the real data. And also we have used the MR, a mixed reality design to support the real site design. Like our camp, we like to more hard. Design. So we also publish several a lot of publications of our urban design work using virtual realities. If you are interested, you can find a paper. And then I think it's my I introduced in the beginning. We start from the human behavior, and then we turn to the design and construction. So the final topic is about the smart city constructions. But in Japan, it's very important to reach the aim of the zero energy house that is issued by Japanese government. So for this kind of research, we have 4 steps. One is to simulate the building form based on land regulation, and the design the solar panel, and find the solution of the energy consumption based on human behavior, and then we consider the energy management in the entire cities and the communities. But just like go through fastly, that's the main concept of the smart city construction in Japan. It's like this: the home energy management system. For each detached house, HAMs, we call it HAMs, can be installed in the detached houses. And then the people can use the generated solar electricity power by the solar panel. They will, it's possible they can also save the generated electricity power to the urban facilities, and then keep the balance of the selling and the generation of the electricity powers. So to keep the balance, so we call it the zero energy house. But it's a little complicated, complicated concept. But it's for the Japanese government use HAMS for the zero energy house construction. And this work will simulate how much the building can generate the electricity powers in the entire years by each month. We simulate how many years can be used for the solar panel, and how much electricity power can be generated by the solar panels. And also we simulated the reflection from the surrounding buildings to consider which wall is also possible to install the solar panel. And this is some kind of simulation for consider the daylighting for energy saving. And this is some kind of simulation work we are doing. And we consider the opening size, I mean the window, that can use the daylighting, and then we can turn off the light if the daylighting from the outside is enough. And then this is possible for energy saving. And also, we simulate all the house in the communities and try to keep the balance. How to keep the balance of the generation of the electricity powers by the solar panels, and between they can offset the amount they can buy from the facilities in the cities, just like keep the balance of buying and selling for of the energy electricity powers. Yeah, also we have several publications. If you are interested, you can try this publication for more information. Okay, it's all my research introduces. So my research is support the policy making and planning and design. And so we use the GIS technology and virtual reality technologies. So my topic, so that's me. The reason I designed my topic as urban simulation for urban planning and design. They also relate to the environmental issues. And I hope this topic is related to the conference. And finally, I'd like to introduce some publication, some journal and book series editing. And we also organize one international, we call it international communities of specialties. We edited one journal, we cooperated with Japanese government and published in this stage. Is international review for spatial planning and sustainable development. And also we edited one series with Spinger. The book series name is Spatial Planning and Sustainable Development. And I hope you can, if you are interested to publish with us, you can submit a journal to the Journal International Review for Spatial Planning and Sustainable Development. And also, you are interested to publish a book with us, you can contact me and then send one proposal, and then we can consider the publish the book in the book series, Spatial Planning and Sustainable Development. And thank you very much. I hope I did not occupy too much time. And now I'd like to close my speaking. Thank you very much.
Thank you very much, Professor Shen, for such an interesting question. And of course, it's still related to our theme today, how we talk about the sustainable development. And maybe in the discussion with the question and answer, we will discuss more on the how the urban planning in your area address the sustainable development related to COVID-19. And let's move to the third speaker for the plenary session, Associate Doctor, Professor Dr. Zulkifli Abdul Karim. He is an associate professor